For this week's interview questions, we were tasked with explaining the difference in intersections for the scenario. So, an intersection of two sets contains items that are both of the two sets, and a union of two sets contains all the items in either set. So, I wanted to share my notes with you a little bit about kind of my thought process. And let me just get that out of the way about my thought process and kind of what I've learned throughout this week. So I've laid out my usually fairly messy notes into something that you can follow along with. So first, let's start with finding the intersection of the two sets. Um, First, to find the two sets without using any built-in methods, what I have found is you can iterate through one set and check for the presence of each element within the other set. And then, of course, my overall approach I've lined out in this next little section. My approach is to create a new empty set to store the result in, and then iterate through the input sets. Then, once that's done, for each element, it's going to check and see if that exists. And so if it does exist, then I'll add the element to the results or the set of the results. And of course, this is, I think, probably one of the more efficient ways to do it. Um, Down here, of course, is my step-by-step sort of discussion. And then I'm able to scroll down at all. Thank you. Here are some of the notes that I took about the different, what I'd like to call cases. There's, of course, the standard case, which you can see here. And then you have the no intersection kind of case, which is here. And of course, I don't want to read all of this out for you. And then, of course, this one I actually learned a little bit about, and it interested me the most because it is a set that is a subset of another set. And that can come in handy with a lot of things, learning how to do subsets of sets. So now let's move on to finding the union of two sets. And of course, in order to find the union of the two sets without using any built-in methods, because I know there are many ways to do such, we want to combine all elements from both sets into a single new set. So here I've written down my approach to do so, which is where I create the new set with all the elements from the first set, and then I will incorporate all of the second set and its elements into this same new set. And then once that's done, we'll set the data structure up automatically. And then, of course, luckily for me, the software handles the duplicates, which is very nice. And once that's done, um, it'll basically make the union, which is amazing. Of course, down here is more of a step-by-step on how to do such. And then, of course, uh, I learned a little bit more. We learned a little bit about the standard case, but these identical sets I think is nice. Because one thing I like when programming is to find not identicals, but to make sure that nothing that I have is identical. No redundancies. Redundancies within a project or within code can often lead to lots of messes. So having uh, a piece of software that takes everything and makes sure there's no duplicates and no redundancies, I believe is very powerful technology. But I think that is where we will end it for today. Thank you for coming to this interview and for watching.